I am doing example 5. I'm doing example 5. So it's 5a, the integral of 1 over x, natural log of x. Now, whoops, ln x. Yes. All right, here's the bad news. There's almost guaranteed one of these, either A or B, on the AP exam. They like this question because they think it's clever. Okay? All right, so what I'm going to do is rewrite this a little separately. 1 over x times 1 over natural log of x. Alright. Do you see that you have the derivative of one of those pieces in the problem?
Yes.
Okay, what do you see?
1 over x is the derivative of... Wait.
Yeah, you're on the right track.
Is the derivative, or the derivative of 1 over x is natural log, or
No.
Or is the integral of natural log?
The derivative of natural log of x is 1 over x.
So it's the integral of ln x.
So it's going to be... Alright, so
Or ln x is the...
think of it as... Alright, let's do the u substitution. So u would equal natural log of x, and du equals 1 over x dx. You understand that?
Yes.
Alright. So when I do the rewrite...
Well, why isn't there absolute value with the x now? With natural log of x?
Okay, when you integrate, you take the absolute value. This is the original problem.
Is that a real tattoo?
Oh my.
Yes, it's a real tattoo.
Whoa. Gotcha?
No, I'm lying.
Sorry, that was good.
Alright, now, so when I do the substitution, I have 1 over u du. Okay, I have 1 over u du. Right? ln of x has been replaced with u. 1 over x dx has been replaced by du. So this becomes natural log of the absolute value of u plus c. But what's u?
U is
Natural
ln.
log of x. So the answer to this question is the natural log of the absolute value of natural log of x plus c.
So that's pretty simple as long as you know the...
As long as you're not like...
So now we're doing u.
Well, here's the thing. You have now seen this problem. This is a problem you have seen, and it will appear on the AP exam because they like this question.
You owe me soda if it isn't.
I don't think he didn't have to.
I can't take your word for it that it's not on the test because I'm not allowed to look at it. All right, let's look at example B.
Oh yeah, I would have to tell you. Well, there's some people in here who would never lie.
Wait, don't you have to take the test though?
No. Wait a minute. Why do you think the teacher has to take the test every year?
I don't know. I know the ACE teachers do.
The ACE teachers have to take the test every
You
year?
have to take it to be able to teach it.
No, that's for like chem and stuff, because like we have to do a lab, like a practical.
Yeah.
So like our like chemicals might be slightly different. So like if we get different yields or something, like they want to compare it to the teacher's results to see if we mess
Okay,
up.
that's something different.
Yeah.
No, but I know...
That's not a matter of knowledge. That's a matter of what your resource is like.
To become an AP teacher, you have to take the AP exam.
No, you don't.
That's what Miss Gibson did to become a psych teacher. Cause she...
So a typical AP training course, to pass the class, you have to take some version of the AP exam, generally speaking. So yes,
So it's
I
not-
did take it, and I got 100%.
You got 100.
I got 100%.
No,
All right.
you're lying.
Yes, I am. All right.
Lying.
Okay, now let's look at this one. Again, I'm going to rewrite this as 1 over x times natural log of x dx. Okay, so this time natural log of x is in the numerator instead of the denominator. So what's u going to be this time?
1 over x.
Natural log of x again.
What?
Because du is 1 over x dx.
But
So now it's u du. Right? I replaced the natural log of x with u, and I replaced the 1 over x dx with du. So this becomes 1/2 u squared plus c. So it's 1/2 natural log of x squared plus c.
Yeah, what's
so it's simpler.
When I integrate u du, that's same thing as u squared over 2.
Especially
I do not
five.
want to re-explain that 1/2 u squared and u squared over 2 are the same thing.
I understand that, but how is it u squared over 2?
It would be.
Power rule. Add 1 to the exponent, divide by the new exponent.
I don't.
You forgot the basic rules?
I don't understand. It's u du.
Right. When you integrate it, you get u squared over 2.
So u is.
Okay, what's the integral of x dx? X squared over 2. Okay, this is just you having a bad one.
No, I think
It's called a
the
mystery
one
word.
for u is ln, but the one just or the u just now is just ln. I think that's what he's. I don't know.
No, he's asking where did this come from?
Oh.
Because you gotta integrate. And then the du just.
He's having a brain cramp.
Wait. Why did you choose to bring the 1/2 out? Why didn't you leave it over 2? U squared over 2.
I prefer 1/2 u squared as opposed to u squared over 2. That is just a personal preference. I prefer to realize that it's the coefficient as opposed to it is a divisor. Alright. So it's one of these two will be on the exam. So Brendan,
Yes.
one of these two is on the exam. I'm not guaranteeing A is on the exam or B is on the exam. It's one of these two is on the
What are you
exam.
placing your money on?
I'll go for that soda.
Alright.
Alright. I'll go for a 12-pack.
Are you going for A or B though? Are you-
One of them. I'm not guaranteeing one. No, I'm not saying that's guaranteed on there. It's one of them is on there.
Alright.
Alright. Okay, moving on. Alright, so you should see this page, not as badly as mine. Okay, so you know these one, right? Integral of sine is negative cosine. Integral of secant tan is secant. Integral of secant squared is tan. Integral of cosine is sine. Integral of cosecant cotan is negative cosecant. Integral of cosecant squared is negative cotan.
Can you zoom in?
You should know this.
I know, it's easier to just see it from now.
Alright, can you see it now?
Perfect. Oh, it was able to focus it?
Where's the plus C?
Right
Oh,
there.
it's of you?
I can't even find that paper.
That's like the very.
It's on page 268. It's the same page I've been working on.
I was doing
What's secotanu?
What?
Seen that.
Secotanu.
Seen them.
Wait. We're on page 68.
Yeah.
Salud.
That was page 268. That's page 2.
3.
The homework is page 270. Alright, moving on.
Wait, what's secotanu?
It's German.
Oh, it's just secotanu.
Hey, did you know that there's another page that has the same problems as you just did?
No, I did not know that.
273 has the same problems.
Really? I believe you. Alright,
Oh, yeah, you're right.
okay.
Were you doing it on the? Were you on the?
Yeah, he was on the wrong page. Okay. Well, Zion, I hope you're enjoying this. Alright. 6A.
I actually went
Where-
back
where-
and watched that video you recorded.
Where is Zion?
Hey, you know I subscribe to your YouTube, Mr. Spencer?
I'm sorry?
I'm a subscriber to your YouTube. My suggestion on YouTube is all your videos.
You probably have more subscribers than most of the people in
Did you
this.
become 1,000 there?
Negative cosecant u plus c and then cotangent u plus c.
Alright. So now I'm doing tangent x dx. Right? Notice, tangent is not one of these.
No.
Tangent is not one of these. Because we need logarithms to do that, right? So tangent x is same as sine x over cosine x. Agreed?
So why is that the answer?
Say what?
Why is
Oh, never mind.
Right? So tangent x is the same as sine x over cosine x. So what's the derivative of cosine?
Sine.
Negative sine. So I just need a negative SIGN up there and compensate for that negative, put a negative over there. I'm taking the derivative. Derivative of cosine is negative sine.
So you're just like use substitution.
Why do you have to put the
Huh?
second one on the outside?
Found it.
Compensate, because a negative.
I know, but why can't you
Yeah,
put
it will make it positive, but then I'm stuck where I was before, where I needed the negative. Alright, so this becomes negative natural log of the absolute value of cosine x plus c. Right? I have the derivative of the denominator in the numerator, so that's a log. Negative natural log of absolute value of x, absolute value of cosine x plus c. And because of that negative sign, I can rewrite it as natural log of secant x plus c.
Why?
Okay, so the question is, why does that negative sign allow me to write cosine as secant? Right? So here's the reason. If I have, I'm going back to this thing, okay? That negative sign is the same as like a negative 1, right?
Yes.
Whenever you have a coefficient of a log, you can use it as an exponent of the argument of the log.
So it's like 1 over cosine.
Okay.
So it's like 1 over cosine.
Do we? Need
1
to
over
do that?
cosine is equal to secant.
Do you know that?
Do you need to know that 1 over cosine is secant? Yes, you do.
No. Do we like if we had stopped at negative ln negative natural log of cosine x plus c? Would we gotten that wrong?
Okay,
Or we
so
had to go that extra
where would this question appear on a test?
step? A multiple choice.
Multiple choice. So that would depend on what choices they gave you. Chances are good they're going to give you this one.
What if they gave us both?
Well, if they give you both of them, no, they couldn't give you both of them because they're both the same answer.
Yeah, you're right.
Yeah.
Can you explain how you took the integral?
This is some weird.
How do I get from here to here? All right.
Some weird.
Okay, ready? I'm re-explaining that one. So I am looking at this first, right? Sine x over cosine x.
Well, I can't see.
All right, so I'm looking at this first.
Yes.
Okay, so and I realize the derivative of cosine is almost up there, right? It's only missing a negative. So let's just do this. U equals cosine x, and then du equals negative sine x dx. Yeah?
Yes.
All right. So I have a sine x dx. I don't have a negative sign. So I'm gonna make it negative du equals sine x dx. Do you understand that?
Sure.
All right. So now I'm gonna do the substitution. I'm replacing sine x dx with negative du. Well, let me zoom out a little bit. So I'm replacing the sine x dx with negative du. So it's negative du over u.
Sure.
Right? That same thing as 1 over u, put the negative outside du. So I took the negative outside, read the du over on the side, that's same as 1 over u. You agree with that?
Yes.
So that's negative natural log of the absolute value of u plus c. You agree with that?
That's what the issue is.
That's a basic integral. That is a basic integral.
I'm so mad.
Don't let the fact that it's a different letter fool you. If I have integral of 1 over x dx, do you agree that's natural log of absolute value of x? Yeah.
Okay, so for the step where you have negative du over u in the integral, and you go from, can you make it like du of 1? How do you do that?
The camera's pretty low. It's good at night, but like in the daytime. Like,
What is 1 times 5?
And it also is motion.
What is 1 times
So, like, if it sees a bird or
x?
you're not even looking at the
And then you miss.
well, like,
Okay?
Yeah.
So if I have x squared,
like, make
can I write that as 1 times x
highlights
squared?
it from last year's good.
Yes,
Like,
If I have
so far
du,
this year,
I can't write that as 1 times du?
This
but where did it, I didn't,
Does that have,
the
like-
original one real quick?
like someone in your family or something just like try.
Oh, you took the du out, I didn't even see that, I don't know.
Second fill
You
up
get
my
our
water bottle.
bottom camera, set it up at the top.
I didn't read it right, I'm sorry.
Alright, okay? So negative natural log absolute value u plus c. So it's negative natural log and u was cosine
You guys
x.
like a lot of people.
Alright?
I think it'd be cool to invest.
Okay, so that is so. And then we said that's natural log of secant x
Ours is
plus c.
Ours is nice.
So you should know both of these. Okay? This should not be a big leap to go from negative natural log of absolute value of cosine x to natural log of absolute value of secant x.
It's our new
All right.
for film.
So that is the integral of tangent x. Right? That's the integral of tangent x. Let's do the next one, which is integral of secant x.
Its own.
All right. Now, what I'm about to do for the integral of secant x, you can
It
either
was literally zero effort. Like, but I don't think you can.
memorize the process or just memorize what the integral is. Because the process is like pulling crap out of thin air. Okay? So the technique I'm about to use to find this integral is like pulling just random thoughts out of thin air. Okay, well here's the thing. So you can either memorize the process or just memorize the answer, which is perfectly legit. Just memorizing the integral of this, okay?
Say show you work.
You are not required to ever show your work for this. But I'm about to show you the work just so you know where it's coming from.
Just secant x dx.
Also, our
Well, but we can memorize tan x dx too, right?
Yeah.
It's messed up down.
Alright. So you can memorize any integral.
I
Okay?
think it would be smart.
But this one, so what I'm going to do, I am not changing this to 1 over cosine. That does not help me in this problem. What I'm going to do is multiply this thing by 1. But when I multiply by 1, it's going to be an incredibly nasty looking form. It's secant x plus tangent x over secant x plus tangent x. So what I've done, what I'm trying to do is make it look like something I am familiar with. Right now, you don't see that.
And then it'd be tan when you're done. Right?
Or something, yes. Okay, so remember, this is secant x. If I have secant x written like this, this is the same thing as secant x over 1. But this is 1, the number 1. Okay, this is the number 1. Because the numerator and denominator are the same, I am multiplying this expression by 1. It's just a really funky looking form of 1.
You're just gonna get the two derivatives.
Yes. So that becomes secant squared x plus secant x tangent x over secant x plus tangent x dx. As Matt just pointed out, the derivative of secant x is secant x tangent x. The derivative of tangent x is secant squared x. So what I have in the numerator is the derivative of the denominator. And when you have that form, that is natural log of the denominator. So that's what the integral of secant x dx is.
Can you use natural log every time the derivative
No.
of the denominator?
Wait, what? Ask your question again.
Can you use natural log every time the derivative of the denominator is equal to the is equal to the numerator?
Yes.
Okay.
But it's got to be the whole denominator, not just part of the denominator.
Yeah.
Alright, so Brendan's question was, if you have the derivative of the denominator in the numerator, can I always do a natural log? The answer is yes. But it has to be the derivative of the whole denominator. It can't be like secant x tangent x to the second power. Okay? But if it is that to the second power, then the numerator has to be, like, you got to use the power rule and chain rule on that to get that in the numerator. So that's a big ugly mess.
But
Go ahead.
the whole like ln thing with the numerator and the denominator is use substitution.
Yes. Alright, so that is the integral of secant x dx. Natural log of secant x plus tangent x. As someone pointed out, you can just memorize this integral.
Dude, they didn't even
You can
record
just
the
memorize
first
this integral.
one.
You are not required to reinvent the wheel. Like,
Sign on camera.
right, this is considered reinventing the wheel, doing this technique. Alright. So now, so on the bottom of page 268, you have this chart. So now, you can fill in the integrals of all 6 basic trigonometric functions. Okay, we haven't done cosecant yet, but I will show you what that is. Okay, so the integral of cosecant x is negative natural log absolute value of cosecant x plus cotan x. Okay, so notice cosecant always has a negative with it, and secant doesn't. So that's the last box that needs to be filled in. Right, so this one. So sine, you know the integral of sine. What's the integral of sine? Negative cosine, right?
Yes.
Huh? What's the derivative of cosine? Right, so you change the sign. Remember, you're doing it backwards. And then integral of cosine is positive sine. Yeah. And integral of tangent was what? You can do negative natural log of cosine u or the natural log of secant. Okay?
On the multiple choice, if we just remember tangent, it's better to remember secant, right? Because that's the most simplest form.
Yeah.
Actually, it's 50-50 which one shows up.
Really?
Yeah. I mean, I agree with you. That's the more simplified form, but that comes up just as often.
That's easy because secant.
All right, so this one is natural log of sine. Let's see.
Is that just because, is that just like why, that's just because it's sine? Or like
That's a good question. Maybe I'm doing it wrong. Or maybe my memory is wrong. So let's do that real quick. So that's cosine u over sine u, right? Cotan is cosine over sine. The derivative of sine is cosine, so this is natural log of sine. So no, I'm right.
Alright, I just didn't know if there was like.
It's okay. It's okay. All right. And then we just did secant, so that's natural log of absolute value of secant u plus tangent u plus c. And cosecant is negative natural log of cosecant u plus cotan u plus c.
It's kind of wild. It's a lot. So we have to memorize every single one of these?
Yeah.
Your ends look like U's.
I don't, because I'm gonna be using my notes on this.
Yeah, I'm gonna be using my
Do we have to memorize those for your test?
Yeah.
And your U's
Well,
look
I
like
mean,
A's.
they're not going to appear more than one or twice on a test. Ready for page 269?
If I can find it.
It might be on the other side. There you go. That's not 269? You got it? All right, ready? 269.
We got it definite interval.
We got definite integrals. In fact, all of this on page 269 are definite integrals. All right.
I don't like this.
You don't like this? Why don't you like this?
It doesn't look like.
It looks like mighty entertaining.
Yeah, like that's great.
All right, what is cosecant squared x minus 1 equivalent to? Cotan squared. So you rewrite it as square root of cotan squared.
This is probably a dumb question. Could you just write it as just cotan x or no?
Okay, so yes and no. You can, but why can you?
It's absolute value.
It's absolute value, right? But do I have to worry about absolute value in this problem?
No, you can't.
It's because it's between pi over 6 and pi over 2 where cotan is all positive.
How do you think of that in your head? Like,
Think of what in my head?
how do you know that?
All students take calculus.
What he said. Right, this is the first quadrant. Pi over 6 to pi over 2 is in the first quadrant. All trig functions are positive in the first quadrant.
Mr. Schweitzer, what's that called when you, like I know how you, like, cosecant squared x minus 1 goes to cotan squared x, but what is that, what kind of function?
Pythagorean identity.
Wait, switch logic. Like, you know how when you take a square root of something, the teacher always says you have to put plus and values next to it?
Tournaments.
Is this
No, I disagree with that statement.
Okay, well, is this
What
like-
the teacher is saying is when you're solving a problem, when you're solving a problem, you take the square root. You have to do plus or minus. But when all you're doing is simplifying an expression, you usually have to put absolute value, not plus or minus. Okay, but why did I not put absolute value on this problem? The thing is, it's not wrong to put absolute value, it's just not worth the effort. Wait, I didn't put absolute value because I am in the first quadrant when I go from pi over 6 to pi over 2. And all trig functions are positive. So the absolute value of positive is you just keep the same thing. So in a sense, I'm just being lazy by not writing the absolute value. But I am justified in not writing the absolute value. Okay?
Thank you.
Alright.
It's just negative square root 3.
I don't know. Alright. So what is the integral cotan?
ln sine absolute value sine u plus c.
Thank you. So sine x. So I'm going to take that. I don't need a plus c because it's a definite integral. I'm going to take it from pi over 2 to pi over 6. Alright, so it's negative. So it's natural log of sine of pi over 2 minus natural log of the sine of pi 6.
That's 0. 0 minus.
Whoa, whoa, whoa. What's sine of... Oh, yeah. Everybody follow that that's 0?
No.
Okay. Alright, so let's go through the process. So,
I don't know that.
alright. Sine of pi over 2 is 1.
Oh.
Okay? And natural log of 1 is 0. Sine of pi over 6 is 1/2. So this is 0 minus natural log of half. That's same thing as, so I'm going to delete the 0. I'm not going to bother to write the 0. If I take a negative inside, that turns into natural log of 2.
What?
Alright, so negative is same thing as natural log of 1/2 to the negative 1. And 1/2 to the negative 1 is 2.
Should we know?
Oh, because you pulled the exponent out and then you put it back in.
Was that far enough?
So that means it'd be 1/2 over 1, right? So how does that?
No. It's 1 over 1/2. Not 1/2 over 1.
So then you just bring the fraction up.
Okay, most definitely this will be on a multiple choice answer. You will not find negative natural log of half. You will find positive natural log of 2. Okay, that's definite.
What's the ln of 2?
I don't know. Like negative 0.1 or something. I don't know. I mean, that could be completely wrong.
How do they come up with natural log?
It's log base e.
I know, but like how do they come up with e?
Yeah.
It is, e is the number. Okay, so whenever you do y equals a to the x, okay, and you take the derivative of that, right? It's y prime equals a to the x times the natural log of a, right?
No. I literally just thought it was a to the x minus 1.
So we're going to ignore that comment and go with mine, all right? So you chose the number e so that it would be e to the x times the natural log of e, and natural log of e is 1. So they played with numbers until they come up with one where the derivative of the function is itself.
So they just determined that e was just going to be the number that worked out with natural log.
Yeah.
Wow.
You guys believe that? I don't know the answer. Oh, it also does this. If you take the limit as n goes to infinity of 1 plus 1 over n to the n, that's also equal to e.
But that's 1 plus natural
Right,
log.
so the thing is, this number e comes from a bunch of places.
But that would be 1 plus natural log, so, right?
No, I'm not taking the derivative or integral. I'm taking the limit. I'm taking the limit here. I'm not integrating. Alright, let's go on to B. So that was an aside, random thoughts by your teacher. That was not necessary for this lesson.
Schweitzer aside.
All right, we are moving on to what? B? B. So this is from 0 to pi 4. By the way, if we don't finish all these problems, the homework is still legitimate.
Yeah.
Great.
I've already done all I need to do for your homework to be doable. All right.
All the odds.
Yeah, all the odds. Okay, so what is 1 plus tangent squared x equal to? Try again. Try it again. Secant squared.
So these are good for.
Right, so it's square root of secant squared,
It's just secant.
which is just secant,
It's in the first quadrant.
because it's in the first quadrant.
And it would work. It doesn't. So
And what is the integral of secant?
I think it's also older.
So this one, it's easier to just leave it negative natural log of absolute value of cosine x. Because I don't want to work out secant x.
Yeah.
Right? I don't want to plug in these numbers in there. Well, I guess it's not that big.
So the integral of secant x was secant u plus 1.
How did you do
God, dog. Thank
And
you.
if you want it to be
I was about to say,
1080,
Yes. I was completely wrong. All right. Natural log of secant x.
Math teacher being wrong, I don't have that.
but like you could also switch battery at halftime.
Surely that's happened many times before.
I mean, it has, but like,
I'm gonna say.
they weren't as good as you are.
Wait, so is it still negative or not?
No, it's not negative. I made a mistake.
Uh,
Alright. I had tangent on the brain. Not sure why. Alright. So it's natural log of secant of pi over 4 plus tangent of pi over 4
We just
minus natural log of secant of 0
It's only
plus tangent of 0. Okay? Secant of pi over 4 is square root of 2.
How would you find?
And then these are 50,000.
Secant of pi over 4, unit circle.
If he
So it's cosine, it's 1 over cosine of pi over 4. Cosine of pi over 4 is square root of 2 over 2. If you take the reciprocal of that, you get square root of 2.
You can use that for probably indoor too.
Plus 1.
And you
And then
can
it's
make like
minus
type
ln.
videos and stuff. Yeah.
ln of what?
0.
Okay, what is the secant of 0?
Undefined.
1.
I need to make a highlight.
Right, cosine of 0 is 1, 1 over 1 is 1. Tangent of 0 is 0.
Okay.
So it's natural log of 1, which is 0.
And I have 2 already.
So finally,
But only
final
one.
answer, natural log of square root of 2 plus 1.
Um,
The voices you're hearing, Zion, are Brendan and Isaac, who are talking while I'm talking. So I apologize for that.
Can you actually hear us?
My mic is very strong.
Really? Oh yeah, I was listening to it and I could hear Will asking questions.
Go up? Wait, where do you want me to go? There?
Oh, you actually have the actual microphone. That's cool.
Yeah.
Yeah.
What are you doing? Stop that! That was Brendan tapping the microphone in case you hear some weird noise.
it sounded like we're on a podcast.
All right, moving on. Ready?
Wait, I got a question.
Go ahead.
How did we? It was like you were subtracting ln of 1,
Correct?
and then it just went away.
What's ln of 1?
You could buy like 2 of these.
Wait,
ln of 1 is 0, so it's minus 0.
how do you know that?
How do I know the ln of 1 is 0?
Yeah.
Same reason why I know 2 times 3 is 6.
It is.
2 times 3 is 6. I thought it was 12.
Only on Tuesdays. Oh wait, today's Tuesday.
Yeah. So it is 12.
All right, ready for next example. 8A. 8A. All right, 8A. How are we doing on time?
10:23.
You got 2 minutes? Oh, okay. All right.
No, it's the exact same thing, except it's
All right, cosecant, it's his average value, so you're going to do, so from pi over 6 to pi over 4, cosecant x, 1 over pi over 4 minus pi over 6.
Yeah, so just to be clear though, like, when they give us an interval, it's the second point that's the top, and the first point that's the bottom.
It's the bigger one minus the smaller one.
Wait, hold on. So, why is the stuff being multiplied on the left side?
Because it says to find the average value. So average value of a function is the integral of that function divided by the length of the interval.
I remember that.
Why is it, and you said it's the bigger number minus the smaller number?
Yeah.
And then, should there be a dx in here?
Yeah.
You said integral of the function divided by.
But,
The length of the interval.
if the interval was like written backwards or something, like what if it said on pi over 4, comma pi over 6, would you still write it like that?
Yeah. And by the way, that would be a major typo if they wrote that interval that way. Because interval notation is always small to big. Alright, here we go. So what is the integral of cosecant x?
And cosecant x is
ln cosecant x plus
cosecant x
cosecant
plus
x
cosecant
plus.
Okay. What's pi fourth minus pi sixth?
Negative
6
pi over
minus 4? No.
That'd be
What's
negative
2? 3? 2? 3. 3 minus 2?
Pi over 6.
Negative pi over
3
2.
minus 2?
Pi over 12.
Pi over 12. So 12 over pi?
Oh, we just gotta find like a coma.
pi over 12.
So 12 over pi. Alright.
How?
It's the reciprocal. Right? It's 1 over pi over 12. Yeah. Alright.
Yes.
Negative natural log.
What's negative?
Remember cosecant was negative natural log of cosecant x cotan x. Taking that from pi over 4 to pi over 6.
You ever put ln again, like ln of cosecant pi over 4 plus cotan pi over 4 minus ln again?
Yeah. So I want to leave the negative 12 over pi outside and do all this computation on the inside. So it's cosecant of pi over 4 plus cotan of pi over 4 minus natural log absolute value cosecant of pi over 6 plus cotan of pi over 6. Oh, it all fit on there. So negative 12 over pi.
Is it ln or cosecant?
Here? What was your question?
I was just making sure we had the natural log after the minus sign.
Yeah. Alright.
What can I do for points? No teacher gives me points.
That's because they don't like you. What is the cosecant of pi over 4? What's that's 1 over sine, so it's square root of 2.
Yeah.
And cotan of pi over 4 is 1. Minus natural log cosecant of pi over 6 is, that's 1 over sine, so that's 2. And cotan of pi over 6 is square root of 3. Somebody check me.
That's good.
Wait, what?
So you just do whatever you change it back.
So how is cosecant? Okay, it's 1 over whatever.
Yeah.
I'm telling you. That
1 over sine.
code class messes me
1
up
over side
every
is
now and then.
square root of 2 over 2.
Yeah, that looks
Huh?
like you.
It's sine pi over 6 square root of 2.
Sine of pi over 2.
That's 1/2.
Code class.
Sine of pi over 2. But there's no pi over 2 up here.
And pi over 6.
Sine of pi over 6 is 1/2. Yeah.
Hey, it looks
1
like
over 1/2 is 2. Alright. Ready?
So that's the final answer.
No. This is not, sadly, the final answer. In fact, I'm going to do some weird tricks first. So I don't like this negative out here. So I'm going to distribute the negative. I'm not distributing 12 over pi. I'm just distributing the negative. So when I distribute the negative, this is what happens. I get natural log of absolute value of 2 plus square root of 3 minus natural log of absolute value of square root of 2 plus 1. I switch the order. And you're like, what was the point of switching the order? Because now I'm going to do one more rewrite and write it as natural log of 2 plus square root of 3 over square root of 2 plus 1. And that's my final answer.
So still.
And I dropped the absolute values because I know those numbers are positive.
So why do we need to switch? Why can we just?
There's the negative 12 on that.
Because I didn't like the negative on the outside. That was a personal preference.
What if I don't care about the negative?
Whoa, because I thought if it was negative on the outside, it was oh, never mind.
Is that another log like the little like where you can just
Yes. When it's subtraction, it is a fraction. When it's subtraction, that makes a fraction. Yes?
Do you think we can like learn about logs and ln one day?
Sure. Didn't we do that once?
A long time ago.
Yeah, we did that. Well, right before we were doing logs, I just gave you some worksheets to do.
I'm gonna fun that.
Yes.
Do it again.
So I didn't care about the negative side.
Yeah, but you will, because when they give you a multiple choice, most math people don't like that straight negative sign.
Yeah, but I'm just saying, like, what if my fraction is opposite?
you could say
Yeah.
Totally wrong.
Well, there'll be a negative sign outside. It's not that you're wrong, it's just that that won't be one of your choices.
Like the cosine.
Yeah. All right, last example. Ready? 8b. I'm doing 8b.
The most points I've gotten for something was like 3 for making it into a college.
You got 3 points for going to college?
Yeah.
Alright, that's I get 3 points because I'm in college.
Yeah.
I gave somebody 42 points this morning.
For what?
They've been doing Wordles. No, Nerdles.
Oh, Wordle. I've been doing Wordles.
Nerdles.
What are Nerdles?
A nerd version of Wordles.
What is
Is
that?
that what we got credited?
How is it?
No, I've been giving PBIS
That's
reward
what I
points.
meant.
What are wordles?
Nerdles.
Can you
I don't
give me
do
42
Wordles. I do
points?
Nerdles. Nerdle is a nerd version of Wordle. Do you know what a Wordle is?
No.
I don't either. All right.
I play it sometimes. Nerdle. It says reset block, so it must not be appropriate.
Is it something like the more math problems you do, the more points you get?
Yeah, basically. That's more for Algebra 2 kids, though. But only the people who don't need to do it are doing it. So.
That's because they care.
All right. So average value of this one is going to be 1 over pi over 4 minus 0 integral from 0 to pi over 4 of tangent x dx, right? The directions were find the average value of the given function on the given interval. All right, so it's 1 over pi over 4 minus 0, which is the same thing as 4 over pi. And integrate tangent x. Oh, that's the one that's negative something. Right, that's the negative natural log of cosine x.
No, I don't think so.
No?
Oh yeah, it's negative. That's like cosine x. Positive ln of sine. Secant x.
Right, so if I have to find the value, I go with cosine because I don't get as confused as much with cosine. All right, so that's going to be negative 4 over pi times natural log of cosine of pi over 4, which is root 2 over 2 minus natural log of 1. Is what? Right, so negative 4 over pi.
You got root 2 over 2 because of the cosine of
Pi over 4.
pi over 4. Where did
Cosine of 0 is 1.
oh, there's only one thing.
And then I'm going to make it positive 4 over pi and make it natural log of square root of 2.
Alright, so what's the negative do? It's subtraction, you said?
Which negative? The negative here or the minus there?
On the outside.
Okay, so I take the negative into a natural log and I take the reciprocal of the inside. If I flip square root of 2 over 2, I get square root of 2. This is the reciprocal. Right? Because square root of 2 over 2 is the same as 1 over square root of 2. So when I take the reciprocal, I get square root of 2.
Oh, yeah.
Final answer. that's another 45-minute video.
I rewatched the one that went over the study guide and it's actually helpful.